All right, so hopefully you got the answers in the top part up here, right? If f of x equals c, some constant, then the derivative is always 0, right? That makes sense because y equals a number is always a horizontal line, which has no slope, 0 slope, all right? Hopefully you got that if it's linear, f of x equals mx, then you get a derivative of m. Whatever the slope was, that's m because it's the derivative, right? Now, the monomials are a little bit more difficult, the ones with the powers, all right? You have x to the n power. Hopefully you notice that the n came in front, and then it became a power of n minus 1. Okay, if you didn't, go back and look and see if you can see that happening within the patterns now, okay? And then last of all, the last part we did was we had a constant in front, and we noticed that the constant didn't affect anything. The constant just stayed there. We were able to follow the same rule as before. It's just then there was a constant in front that just stayed in front. All right, now that's because it's being multiplied. Okay, now I wanted to do a quick video on this just because all 4 of those rules are not in your formula packet. The only one that's in your formula packet is this one right here, right? You can see it. It's the derivative of x to the n power, and it gives you n times x to the n minus 1. Okay, now I wanted to show you how you can get each of the things from above from that, right? Really, this one right here, you need to know. You just need to know that the derivative of a constant is 0, right? Because it's a horizontal straight line. So anytime you take the slope of a constant, the constant is constant. It's not changing. And so therefore, the slope will be 0. Okay? This one, you can actually do this one using the rule from below, because you could say that f of x equals m times x to the first power, right? If there's no power, it's just a 1. And so if we follow the rule from here below, it says to take the n, put it in front, and then subtract 1 from the exponent. So if I take the 1 and I put it in the front, that would be m times 1, which is still m, right? And then if I subtract 1 from this, then I would get x to the 0. And x to the 0, of course, is 1. And so m times 1 again is just m. So you can follow that rule. Most of you will get to the point where you say, if it's a number times x, then it's just that number. All right. Hopefully you kind of got the idea of what's happening here. I wanted to just show a couple other examples really quickly. If I had, for example, y equals 3, I'll make that a 3, x to the 5th, then I would follow this rule by saying, okay, well, this is the same thing as 3 times x to the 5th. I can follow the rule in my formula packet by taking the 5, which is in front, the power, putting it in front, and then subtracting 1. So this would become, if it's y prime, and this is, I'm using a different one of the notations here, so you get practice using different notations. The 3 stays there. It's now 5x to the 5 minus 1, which is 4, and that then gives us 15x to the 4th. And so that would be what we call the derivative function, okay? Now, often we say that this is the derivative for short, but in reality what this is the derivative function. It's a function that now I can put any x value in, right? If I wanted to know for this specific graph, what is the derivative or what is the gradient at x equals 3? Then I would take 3 and put it in for x, and it would give me a value, right? I can put any value in for x, and it will tell me what the derivative or the slope or the gradient will be for that original function. That's the purpose of the derivative function, to allow me to find the derivative or the gradient of the tangent anywhere along that curved function. And this is really neat, because now we don't have to punch it into the calculator and graph it and all those things every time. As long as it's a polynomial and it follows these rules, then we're going to be able to do this. Now, this doesn't give us the information we need to deal with logarithms or trig functions or, division or anything like that, But what it does do is it allows us to work with a simple polynomial. For example, if I had a quadratic equation, which was f of x equals 2x squared plus 3x minus 5. Now, one of the neat things about this, these derivative rules is that if there's a plus or minus, you can treat each piece individually, right? You don't have to do the whole thing at once. And so the first thing we're going to do is we're going to look at the first piece there. Okay, so I'm going to just look at the 2x squared here, right? So that's going to be 2 times, remember I'm going to bring the power forward, and then x to the, and then subtract 1 from the 2, which would be first power, plus, and then I'm going to look at the next part, which is 3x. And we know that the derivative, we had it up here, the derivative of a number times x is that number. And then in the end, we have a minus 5. And the derivative of any constant, even a negative, is 0. So I could go minus 0. And I put this all together, and I get my final answer, which is 4x plus 3. And that is the derivative function. You can now take any x value. If you had this graph and you said, oh, this graph looks like whatever. You know, I don't know what it looks like, but let's just say it looks something like that. What is the slope right here? Or what is the value of the tangent or the gradient at that point? You could say, well, x right there is 3. So let's put 3 into the function, and you would say, oh, the value is 14. The slope or the gradient equals 3 times 4 plus, 3 times 4 is 12. That would be 15. I promise I can do basic math. All right, the slope would be 15 at that point, right? And I didn't have to graph it. I didn't have to do any work. The only reason I drew the graph was to help you visualize what's going on here. So the idea is that this is allowing us to find a function that will allow us to find the gradient at any point on any parabolic curve. We will learn how to deal with other things later, but for now, you've got your calculator, which means you can essentially deal with any curve, any gradient on any curve that you can actually graph. All right, so that's it for now. Pay attention to the big ideas, that this is the only one given you in the packet, so you do need to memorize this one about the constant. Keep in mind this idea of this being the derivative function, which means you can put any x value in and get a slope. We'll talk a little bit more about that next class. And last of all, when you have a polynomial with pluses or minuses in between, this does not work for multiplication and division, but it does work only for addition and subtraction. You can take the derivative of each of those individual pieces, and that allows you in the end to get the derivative function for that original piece. All right, so tonight you're going to practice this. All right, that's it.